Welcome to image labeling using Firebase ML Kit section of this course. So what is image labeling? It is the process of recognizing different things in an image. So you can recognize various entities like animal, plants, food, activities, colors, things, fictional character, drinks and so on with the help of image labeling feature. So it is actually another name for image classification, but now we are gonna use the Firebase ML Kit for image classification. So what we are gonna build in this section? So firstly, we will build an Android application in which user will choose an image from gallery or capture it using camera. Then that image will be passed to our image labeling model of Firebase ML Kit, and after that we will show the result returned by the model to the user. After that we will build another application in which we are gonna use the live camera footage with our image labeling model. So firstly we will display the live camera footage inside our Android application. Then we will pass the frames of that live camera footage to our image labeling model. After that the result returned by the model will be shown to the user in real time. And in order to build these applications, we are gonna follow a 5-step mechanism. So the first step will be importing our starter application code from GitHub. After that, we will create a new Firebase project and connect our Android application with it. Then we will create an image labeler object using Firebase ML Kit. And after that, we will pass the images taken from gallery or camera or the frames of live camera footage to our image labeler. Then the result returned by the model will be shown to the user. So these are the 5 steps we are gonna follow to build our image labeling application in this section. So this section involves building 2 very exciting applications. So let's begin. Welcome to this lecture. In this lecture, we are gonna start building our first application using Firebase ML Kit, and that application is for image labeling. So we are gonna build a simple application in which the user will either choose the image from gallery or capture it using camera. After that, we will pass this image to our image labeler of Firebase ML Kit, and then the result returned by that image labeling model will be shown to the user. So we will start by importing our starter application code from GitHub. So open your browser and manually type this URL, or you can take this URL from project's URL file shared with you. And once this repository is open, just click on this code button and copy this repository link. Then open your Android Studio and here click on this get from version control and paste the link here. After that, make sure that your version control is Git, and here you can specify your project location. So after choosing the location, click clone and this project will be imported in a moment. So now this project is imported successfully and the Gradle is built. So let's firstly launch this application inside an emulator and see what does this starter application contains. So I'm gonna launch this application inside an emulator. So now the application is installed inside the emulator, and that is the GUI of this starter application. So there you can see that we have a background, then above this background we have this image frame, and in the center of this image frame we have this image icon, and below that we have this text view. So now when the user will click in the center of this frame, the gallery will be opened and he can choose an image from gallery. So here you can see that when I clicked it, the gallery is opened. So now let's choose an image. So now I'm gonna choose this second image for now. And now you can see that the selected image is being displayed here. So when the user will click in the center of this frame, he can choose an image from gallery. And similarly, when he will long press in the center of this frame, the camera will be opened and he can capture an image using camera. So here when I long press it, it is firstly asking for the camera permission. So I'm gonna give this permission here. And also the media storage permission because it also need to store the captured image. So now the camera is launching and you will see the default preview for emulator camera. So now the emulator camera is open and that is the default preview for emulator camera. So just click on this camera button to capture an image. And now you can see that captured image is being displayed here. So that is our starter application that user can either choose an image from gallery or capture it using camera with the help of this starter application. And if you have completed our previous section where we learned to use Tensorflow Lite models inside Android, then we covered this thing in detail. So now the next step is passing this chosen or captured image to our image labeling model of Firebase ML Kit. And we're gonna do that inside our next lectures. But before that, let's quickly look at this starter application code. So when I will expand this app folder and go inside this res layout folder, there you can see that we have this activity main. So just open it. And inside this activity main, you will see that the GUI of our application is present. So there you can see that we have the GUI, and in the GUI we have a constraint layout. Then we have both of these image views. One is showing this frame and another one is showing the chosen or captured image. Then we have this text view where the prediction will be shown. And now let's quickly look at our main activity.java. So in this com.example.image classification, we have this main activity. So let's open it. And in the main activity, you can see that we have the same code that we wrote in the section where we learned to choose image from gallery or capture it using camera. So here we just have this fancy looking GUI and everything else is same. So firstly we initialize our GUI components. Then we are setting an onClick listener and onLongClick listener on this frame image view. So when the user will click on this image view, the gallery will be opened with the help of this intent. And similarly, when the user will long press on this frame, then we are gonna firstly check the permission for camera and storage, and if these permissions are granted, then we will open the camera with the help of this open camera method. And if these permissions are not granted, we are requesting for these permissions here. And once the user will choose or capture the image, this onActivityResult method will be called. And here we will check that if the request is initiated for loading the image from gallery, then we will get the image URI here, and then we will convert this image into bitmap format with the help of this URI to bitmap method. And we wrote this method here below. So there you can see that we have this URI to bitmap method. So it will gonna take an image URI as a parameter and return that image in a bitmap format. So here we are taking this bitmap and then we are calling this doInfinite method. And inside this method we are firstly rotating that bitmap and showing it inside our image view. And similarly, when the user will capture the image, we are doing the exactly same thing. So firstly we are converting this image into a bitmap and then we are calling this doInfinite method. And inside this method we are firstly rotating the image before showing it inside our inner image view. And that is because most phone cameras are landscape, meaning if you take a picture in portrait mode, the resulting image will be rotated 90 degrees in anti-clockwise direction. So we need to rotate that image before showing it inside our inner image view. So if you don't rotate this image and comment this line, and instead you pass this input bitmap here and run the application, then maybe when you capture the image using your device camera, the resultant image will be rotated here. So you will see an image which is rotated in anti-clockwise direction by 90 degrees. So in order to avoid it, we are firstly rotating that image and we are rotating it with the help of this rotate bitmap method. So inside this method we have the code which will gonna check the orientation of the image. So if the image needs to be rotated, then it will gonna rotate it, otherwise it will gonna return the original image. So this method will gonna rotate the image if needed, and then we are showing this rotated image here. So that is our starter application code, that we are choosing an image from gallery or capturing it using camera. And now inside our next lecture, we are gonna learn to interact with Firebase ML Kit and how we can add it inside our Android Studio project. So see you in the next lecture. Welcome to this lecture. As in the previous lecture, we imported our starter application code from GitHub, and in that application we are gonna add our Firebase ML kit. But how we are gonna do that? So in order to do it, we firstly need to attach our Android Studio project with the Firebase project, and in order to do it, we firstly need to go to Firebase. So open your browser and here type Firebase ML kit, or you can type Firebase as well. So press enter, and here in the first link you can see that we have this Firebase machine learning for mobile developers. So just click on this link. And now that page is opened, and here at the top right corner you can see this go to console button. But before that you need to attach your Google account with Firebase, and in order to do it, just click on this sign in button. And now here you will add the details of your Google account, so I'm gonna add mine. So press next. And now you can see that instead of sign in button, I have my Google account attached with this Firebase, and now I can click on this go to console button. So that is the landing page for your Firebase console, and here you firstly need to create a Firebase project, and after that we are gonna attach that Firebase project with our Android Studio project. So in order to create a new project, you need to click on this add project button, and after that here you will enter a name. So for example, I'm gonna name it image labeling. And you can choose any name that you like. After that I will click on this continue button and then click continue as well. And after that you need to add a Google Analytics account, but here don't worry, we will use this default account for Firebase. And now click on this create project button and your Firebase project will be created. So now our project is created, and here click on this continue button and it will gonna take you to that project. So that will be the first page for your project, and now we want to attach our Android application with this Firebase project so that we can use the image labeling feature of Firebase ML kit. So here click on this Android icon and it will gonna take you to this page. So here we need to add our Android application package name to attach it with our Firebase project. So move back to your application, and here at the top of this main activity we have our application package name. So just copy this line and copy it after this package and before this semicolon, and move back to that page again and here paste the application package. After that you don't need to add anything because these are optional. So you can also add an application nickname if you like, but I'm gonna skip it and I am gonna click on this register app button. And now here we have this button download Google services.json. So we need to download this Google services.json file and we need to place it inside the app folder of our Android Studio project. So just download this file by clicking on this download button. And now open its location and copy this file. So I'm gonna copy it, and after that move back to your Android Studio project, and here in this app folder you need to paste it. So right click on it and click paste, and this file will be added. So now this file is added inside our Android Studio project, and you can verify it by going inside this project section and here expand this image labeling, then go inside this app folder, and there you can see that we have this Google services.json file. So now move back to the Android mode, and that's it. So now we added this Google services.json file, and this is actually the file which is connecting this Android Studio project with our Firebase project. After that move back to the page again and here click next. And here you can see that we have this line, the Google Services plugin for Gradle loads the Google Services.json file that you just downloaded. Modify your build.gradle file to use the plugin. So in order to use the plugin, or in other words, in order to use the Firebase, we need to add some dependencies inside our build.gradle file. So firstly, inside our project level build.gradle file, we need to add this line. So I'm gonna copy this line. After that, move back to your application, and here in your project level build.gradle file, you need to add this line. So that is our build.gradle file, and we have this project here at the end of it. And we have another build.gradle file, but that is our app level build.gradle file. So just open this project level build.gradle file, and in the dependencies section, paste the line that we copied. So I'm gonna paste it here. After that, we need to place some other things. So move back to the documentation page, and here in the below section, you can see that in the app level build.gradle file, we need to add this plugin. So just copy this second line and move back to your Android Studio and open this app level build.gradle file. And below this dependency section, you need to place this line. So I'm gonna paste it here. After that, click on this sync now, and the dependency and the plugin will be loaded. So now our project is synced, and after following these steps, this Android Studio project is successfully connected with Firebase. So firstly, we created a new Firebase project, and we downloaded our Google Services.json file, and we added this file in the app folder of our application. After that, in the project level build.gradle file, we added this dependency, and inside our app level build.gradle file, we added this plugin. And then we synced our project. So move back to the documentation page, and here you can see that when we click on this next button, the next instruction is you are ready. So we successfully connected our application with Firebase project, and now inside our next lectures, we are gonna use the image labeling feature of Firebase ML Kit to build an application in which we are gonna recognize the thing using image labeler. So see you in the next lectures. So let me summarize the process. So in order to connect your application with Firebase ML Kit, you firstly need to open Firebase and attach your Google account. After that, you need to create a new project, and then you need to attach your Android Studio application with that project, and you are gonna do that by providing the package name of your application. And once you will provide the package name, the file for downloading will be available, that you can download it from here. And you will add this file in the app folder of your application. Then you need to add some dependency inside your project level build.gradle file and inside your app level build.gradle file. And after adding this dependency and plugin, you will sync your project and your application will be ready. Welcome to this lecture. As in the previous lecture, we created our Firebase project and we connected our Android application with that project. And now it's time to build our image labeling application using Firebase. So in order to do it, firstly we need to open the documentation page for Firebase ML Kit image labeling. And in order to do it, open your browser and go to Google. And here type Firebase ML Kit image labeling and press enter, and here in the results, there you can see that we have this image labeling Firebase. So open this firebase.google.com docs ML Kit label images. So I'm gonna open it. And now this page is opened, and here you can see a warning that this page describes an old version of image labeling API which was part of ML Kit for Firebase. The functionality of this API has been divided into two APIs. The first one is on-device image labeling and the second one is cloud image labeling. As we are interested in on-device image labeling for now, so we will click on this on-device image labeling. So just click on it and it will gonna open the documentation page for on-device image labeling, and that is the page. And here we firstly have the introduction of image labeling and the features of this API. After that we have this section for Android and iOS, as we want to build an Android application, so we will click on this Android button. But before that, here you can see different information and you can learn about this image labeling feature by reading this documentation. Like the default model for image labeling recognize up to 400 different entities, and similarly you can see different classes it can recognize. So the base model in image labeling API supports 400 plus labels, and the label include crowd, selfie, smile, dancing, eating and so on. So there you can see that they belong to different categories like people, activities, things, animal, plants, places and so on. So here we have an example where we have an image, and the image labeling model predicted that the stadium is present in the image, which is right, and the second label is sport, and then we have event, layers, soccer, net and so on. So all of these labels are correct. So now let's click on this Android button so that we can see the steps for using the image labeling API inside our Android application. So click on this Android button, and here this documentation page is open. So here we have the instructions to use the image labeling model inside our application. So we will start from the beginning. So here at the top we have this table. So there are basically two ways to add this on device model inside your Android application. The first way is unbundled method and the second one is bundled method. So what does that mean? So the unbundles feature specify that your model will be downloaded once the user will install the application from Play Store. It means that the model is not included inside our application APK, but it will be downloaded after the application is installed. And the bundled method states that the model is included inside our application APK and its size will be approximately 3 MB. So here we have the advantages of bundle and unbundled method. So for example, in case of unbundled method, the model is dynamically downloaded via Play Store. So the application size while creating the APK is not increased, but the user have to wait for the model to be downloaded once he will install the application from Play Store. And the bundled method states that the model is statically linked to your application at build time, and the application size will be increased by 3 MB when your application APK is created. But the advantage is model is available immediately, so user can use the application after installation. So these are the two methods, and after that we have the steps to use this Firebase ML kit image labeling model inside our Android application. So the first step is inside your project level build.gradle file, include Google Maven repository in both your build script and all project section. So open your project level build.gradle file. So I'm gonna open it, and here you can see that inside our build script we have this Google dependency, and similarly inside our all project section we have this Google dependency. So we have this Google dependency inside our build script and inside our all project section. And the next step is add the dependencies for Firebase ML kit library to your app level build.gradle file. So inside your app level build.gradle file we need to add this dependency. But here we have different method for bundled and unbundled approach. So if you are using the bundled approach, then you just need to copy this line and you need to paste this line inside the dependency section of your app level build.gradle file. So just copy this line and move back to your Android application and open your app level build.gradle file, and here in the dependency section I'm gonna paste this line. And that's it if you are using the bundled approach. But if you are using the unbundled approach, then move back to the documentation page, and here you need to firstly copy this line and paste it inside the app level build.gradle file inside the same dependency section. After that you need to copy this metadata tag and you need to paste this tag inside your Android manifest file. So inside the application tag of your Android manifest, you will place these lines. So here inside your Android application, inside this manifest file, you need to go inside this application tag, and here you will place this line, but we are gonna use the bundled approach, so I'm gonna remove it. So now let's click on the sync now button so that the image labeling library of Firebase ML kit will be downloaded. So now the sync is started and it will be completed in a moment. So now our application is synced successfully and the library is downloaded. And now move back to the documentation page, and here the next step is preparing the input image. As inside our application, we are getting the image from gallery or capturing it using camera, and after that inside this onActivityResult method we are converting this image into a bitmap, and we are also rotating that image if needed. So here in this section we will use the approach which is using the bitmap. So here you can see that in the side pane you can see that we can prepare the input image using a bitmap. So just click on it and it will gonna open that section. So here in the Java section you can see that we are creating an input image. So in order to use an image with our Firebase ML kit image labeling model, we firstly need to create an object of type input image, and here we are creating this input image object using a bitmap. So just copy this line and we are gonna paste this line inside this doInfinite method, and here I'm gonna paste this line, and there you need to specify your rotated bitmap. So I'm gonna specify it, and after that you will specify the rotation degree. So we will pass 0 here because we already rotated our bitmap. And after that let's add the import for this input image. So I'm gonna click on it and press Alt plus enter, and then click import class, and this class will be imported. So here you can see that we created an object of type input image, and we created this object with the help of bitmap of the image that user have selected from gallery or captured it using camera. So now we have this input image object, and the next step is passing this input image object to our model. But how we are gonna access our image labeling model? And we are gonna get it with the help of an image labeler object. So here you can see that inside our next section we have this configure and run the image labeler. So to label objects in an image, pass the input image object to the image labeler process method. So firstly get an instance of image labeler. So in order to create an image labeler object, we are gonna copy this line and we are gonna paste it inside our own create method, so that once our application is launched our image labeler will be created. So I'm gonna paste this line here below this load image labeler section. After that add the imports, and now we need to declare this image labeler object above so that we can access it inside our doInfinite method. So just copy it, and after that remove this image labeler, and now at the top of this onCreate method paste the code and add a semicolon. So we declared this image labeler here, and then we initialized it with the help of image labeling.getClient method, and there we specified the default options. So you can customize this image labeler with the help of some options, and you can see these options here inside this commented section. So you can create an object of type image labeler options, and then you can specify the confidence score threshold. So if you want that the label should be shown for the classes which contain the confidence score greater than equal to 70%, so then you can do it with the help of this set confidence threshold method. So here firstly you will create an image labeler option object, and then inside this getClient method you will pass this option object, but we choose the default options. So now we created our image labeler, and the next step is passing our input image to this labeler. So we are gonna use the labeler.process method. So here copy this code and then I'm gonna explain it. So move back to your application, and inside the doInfinite method below this input image we are gonna paste it. So let's paste it here, and here firstly add the import for this image label, and similarly for this onFailure listener, and then add the import for this list. After that, add the import for this own success listener. So now we added the import. So here you can see that we are using the image labeler object and we are calling its process method. And inside this process method, we are passing our input image. And then we are adding several callbacks. So the first callback is add on success listener, and inside this callback we have this own success method. So once our model successfully label that image, this own success listener callback will be executed and this own success method will be called, and inside this method we will get the list of labels that our model recognized. But in case of any error, this add on failure callback listener will be executed and this own failure method will be called, and here we will get the exception that was thrown. So we added these callbacks, and now inside this own success method we are gonna get the predicted labels returned by the model. And in the documentation page we also have a section for it. So below that you can see that get information about label objects. So just copy this section and paste it inside the own success method. So here I am gonna add a new line and then I am gonna paste this code. So here you can see that we are simply iterating this list of image label, and then we are getting the text for each label, the confidence score and the index for each label. So here the text is actually the name of label. So for example, if our model have recognized a banana in the image, then the text will be the banana, and the confidence score will indicate that how much our model is sure about particular label. So if the confidence score for banana was 0.7, it means that our model is 70% sure that it's a banana. And then we have the index, and this index will gonna indicate that in the label file at what index this label is present, or in the list of labels which that model can recognize, what is the index of this label. So now we got this information, and the next step is showing this information inside this text view. So here inside our main activity at the top you can see that we also initialize our text view, and now we can simply use this result TV variable and show the predictions. So here inside this for loop we are gonna show the name and the confidence score for each prediction. So result tv.append method, because we want to show all the labels here. So I'm gonna show this text, and after that we are gonna add an empty string and add some spaces, and then we are gonna show the confidence score. And then we are gonna add a new line character so that the next prediction will be shown on a new line. And similarly, above this process method, we will reset the text inside this result TV, so that when the user will choose the next image, the text inside this result TV will be set to empty string. And that's it. So now the coding of this application is complete, and you can simply run this application inside your Android application and test it. But we are gonna quickly review the process. So firstly, we created our input image object from the bitmap that we have created above. After that, we declared our image labeler object here and we initialize it inside our own create method. And then inside this doInference method, we are passing the input image that we created here to this labeler.process method. And then the result returned by that labeler will be received inside this own success method. And here we are getting this list of image labels and we are iterating it. And then we are showing the name and the confidence score for each prediction here. So now let's run this application inside an emulator and test it. After that, we will quickly review the whole process. So I'm gonna launch this application inside a real device. So now the application is installed inside the emulator, and now let's test this application by firstly choosing an image from gallery. So I will click in the center of this frame and the gallery is opened. And now inside this download section, we are gonna choose an image. So let's choose this first image and see what does our model think about it. And now here you can see that we got these results. So the first result is sky. As the sky is present inside this image, so this label is correct and the confidence score for it is 95%. And the second label is sunset. As you can see that this picture is giving an impression of sunset, so this label is correct as well. And similarly we have this mountain, beach, lake and rock. So all of these labels are correct. As you can see that all of these things are present inside this image. So this image labeling application is working correctly and the results are quite right. And there is one more step, and that is closing this image labeler when the application is closed. So you need to add an onDestroy method here. So here at the bottom of this URI to bitmap, press Alt plus insert and go to this override methods and search for onDestroy. So here you can see that we have this onDestroy method. And inside this method we will simply call this labeler.close method, so that once our application is closed, this image labeler will also be closed. So we are releasing the resources, and that's it. So now we have built an image labeling application using Firebase ML Kit. And inside our next section, we are gonna use this Firebase ML Kit image labeling feature to build a live feed image labeling application. So see you in the next section. So now let's quickly review the process that how you can use Firebase ML Kit inside your Android application. So firstly, you will create a new Android Studio project or import it from somewhere. After that, you need to open your Firebase console and here create a new Firebase project. And then you need to attach your Android application using the package name with this Firebase project. And after doing that, you will download this Google Services.json file and you will paste it inside the app folder of your Android application. Then you will add some dependencies and plugin inside your project level build.gradle file and app level build.gradle file. So in the project level build.gradle file, you will add the following dependency, and inside your app level build.gradle file, you will add this plugin. After that, you need to open the documentation page for Firebase ML Kit image labeling or any other feature you want to use. Like if you want to use the barcode scanning section, then you need to open the documentation page for barcode scanning. But we opened the documentation page for image labeling section, and here we have the instructions to use this feature inside our Android application. So firstly, we added the dependency inside our app level build.gradle file. After that, we created our input image using the bitmap. So inside the application where you want to use this image labeling feature, you firstly need to add the code to choose images from gallery or capture it using camera. So we already had that code inside our applications. So we just created our input image object, and after that we created our image labeler. So we created this image labeler with the help of this section, and then we are passing our input image to this image labeler and getting the result. And after getting those results, we are iterating this list of results here inside our main activity, and we are showing those results inside our result TV. So that is the simple process.